Hello, welcome back to Beneficiary LiveNoding. So we finally arrived at this point. So I decided to kind of make a demo of the whole process, how to create this kind of model. So basically, this is like a result of pattern being generated by something called reaction diffusion. So it's some kind of algorithm, and I probably cannot explain the whole thing, but you can search Google for reaction diffusions, and then also search for Alan Turing and this algorithm, and you will find quite some articles and videos about it. What I'm interested in is how we can generate this pattern. Hopefully one day just simply using Blender, I don't know, via Python or via nodes in Spreadshop, whatever. But I actually, by accident, I found this program. Okay, I already mentioned it a couple of times, and it's you just search Google search for it, and then you will get to this GitHub Gang cross-platform implementation of various reaction diffusion system. This app, this program is really cool. It's available for Windows, Mac OS, and there's one for Linux you can build yourself. And you can actually look at the example, and you can get the simulations of reaction diffusions in this program. And why am I so excited? It's because apparently we can export this out into Blender. And yeah, so I'll try to do this, give a quick demo of the simplest example. Yeah, so just let's get started. I'll close this. Okay. Okay. You just need to download the app, and then you will get, this is the app. This is actually the donut example. There's quite a lot of example already, but you can get the example either from this left panel, which is just this is gonna open the pattern. Basically, this is like presets. Like the bunny one is kind of cool. No, okay. Can open the bunny example. It's often always start like this, like kind of like half blue and half green. It's like a two chemicals that's kind of react to each other. Once you start the simulations, you can slow down the simulations basically, or make it faster, and then see how it reacts until the whole thing settle, and you will see a pattern emerging. There's a lot of parameter here that you can change. I'm not gonna talk everything. There's this formula that you can also play around. There's this parameter that you can play around with. I think the K attribute's very sensitive. If you just make a small little changes and then reset the simulations, let's see, reset, Control R, and then rerun the simulations, you're gonna get a different pattern very quickly. See, in this case, the pattern is totally different now. Let's make this a little bit faster. I'll stop the simulations. So we get a completely different pattern for this bunny. There is one that's kind of interesting. If you go all the way down, interpolations. Okay, image interpolation, you can turn that off, on and off. So you can see the triangles of this bunny. Contour level. Okay, there's a lot of example we can try, like this lion, for example, also quite interesting. See the color. The coloring happens at the leg. You can also paint like your own somewhere, like make a spot from there and start the simulations. And the whole thing, this is something that you can actually export into Blender as a weight, or like a just color, vertex color. I'll show you how real soon. I'm gonna stop this, but I wanna point out another example here. If you actually go to new pattern, if you don't save future, okay, you can start with a 1D image strip. Create it 128 times 1 times 1 image. Okay, this is like the one-dimensional reaction diffusion algorithm at work. So you can see, okay, it's actually generating pattern like that. If I reset it again, Control R, and then hit Enter, you will see it generating these stripes based on this surface. Very interesting. The funny thing is, this is actually can be 3D as well. If you change the dimension, it's almost like a voxel kind of thing. So you can see new pattern emerging, and you can see it in 3D now. So yeah, it's very, very cool. And you can export out the mesh, basically. Export the mesh, you will get the 3D pattern. You can actually start recording together like a frame by frame simulations happening. It's gonna export out a lot of OBJs for you to bring into Blender. If you want to do it that way, that's fine. But I'll show you how we can bring in our like our own objects. So I'm gonna open Blender now. We're gonna need just a 3D mesh, you know, to start with. And the 3D mesh is better be like an interconnected face. So the vertices needs to be sharing face in order for this to work. And the topology and you know, whether you have like a polygon, n-gon, or triangles, it needs to be around the same size as well. So a single cube with 6-sided poly, it will not give an interesting result. But if you go and subdivide this multiple of time, this is going to be more interesting. You will see. So I'm going to use SphereChalk for this, actually, just because it's a lot easier to control the subdivision. So I'm going to use just a simple box and vmesh viewer. Gonna output the vertices and polygon. So we have this guy. Let's make this like 10 subdivision 20 by 20 by 20. So now we are done with this guy. We can calculate normal, smooth shade, whatever. Actually, I'm just gonna leave it like this. I'm gonna show you. Okay, wait. I'm gonna save this quickly first. SV box. And file, export, OBJ. So if I just save it as it is with the default parameter here, there's gonna be a problem real quick. I'll show you. Apparently we need to turn off right normals and include UV. I think we need to turn off right normals. I'm not sure. I'll just leave it as it is for now, like the default. And then if we open, we just import the box into ready. So file, import mesh. This is the OBJ. We just import that guy and then pick the run a pattern on this surface. The second one is also interesting as well, but the first one is what we're gonna use for now. Nope. Okay, this is what we get. It looks like it's it's gonna be working, but once we hit the simulations, it does nothing. It just kind of switch into blue and nothing. You know, I've actually I got this like a few days ago, and I've been wondering why is this not working. And after a couple of trying, and then I asked the creator, I didn't get the answer, but I figured out myself that if you go back to Blender and file, export, OBJ, you need to turn off, I think turn off right normal. I'm gonna export the OBJ once more. So now if we import mesh, nope. Now we get the correct mesh, and if you run it, it's gonna work. Yeah, I don't know why. So you have to turn off that write file export. Turn off write normals. You don't need that. Include UV. UV is actually might be important if you want to use your own texture to start with. But anyway, whenever you reset, Control R, it's always start like this. We can actually go a little bit higher with this poly count. So let's go smaller and go higher here. If we want it to be more interesting, we can actually use maybe use tissue tools and turn it into dual mesh, and you get this hexagonal looking pattern. See, you can see the hexagonal. Okay, file, export, OBJ, and this is like number 2. Make sure write normal is off. Export OBJ, and now we are good. Let's get this app back. File, import, mesh, open. Okay, no. Now we should have the hexagonal pattern, and the simulation should work. I'm not gonna change anything here, but you can feel free to change all these parameters. There's actually only 4 parameters you can change, and whatever you change will affect each other. I cannot explain what it is, but I think that's like there is one that's control the speed of actually the speed of simulation is being controlled here, but this case especially important. Small numbers will change the whole simulation. You're gonna get completely different pattern. So for this example, I will turn off the interpolation actually, so we can see the hexagon. I think that's a little bit prettier. So I'm gonna work like this. I'm gonna save this as a VTU. So this is SP box. Let's save it like that. VTU is actually the format that we're gonna use, and we want to export it into Blender. There's if I'm not wrong, there's like an add-on that deals with VTK or VTP file format. I don't know, I can't remember. Save pattern. I think VTU is the one that we're gonna need to use though. VTU. I'll say VTU anyway. And there's also VTI. I don't know, so many. There's like, this is the format that often being used for like interactive simulations. So yeah, I export it out. So now I want to bring it to Blender, and after like Google searching, I figure out there's actually an app. We need to use another app. So we juggle a lot of apps in this case at the moment. But I'm pretty sure there is a Python add-on that we can use for Blender to convert the VTU or VTI directly. But anyway, this is another program. It's called Paraview. Paraview is almost like a mesh lab. And this actually apparently dealing with a lot of file format, including VTU, if I'm not wrong. So I can simply open up that file just now. Let's find it. Box. SV box video. That's what we save it as. So SV box. Looks like SV box OBJ. Okay, this guy. SV box video. So that's the box. And the first time I used this, this program is almost like a little bit massive. I don't know where to start, but when I hit apply, this actually generates the box. And let's see. Color by solid. Okay, coloring. Solid color A or B. So So the A and B is like the chemical. So yeah, so when I got this, I was so like super happy. Finally, we have something we can work with, and this is kind of similar to what we have in Blender. So enable opacity mapping, so that's kind of cool as well. I'm pretty sure this Paraview program is pretty robust and can do quite a lot, but I'm not gonna spend too much time in here. What else we can have? RGB, HSV, or whatever. Rescale. Oh yeah, apparently we can kind of adjust the strength as well. I actually want to make the red one like as high as possible, and the blue one as kind of increasing the contrast between the two. I'll just gonna leave it like this for now. The most important is to bring this back into Blender. So export the scene, save it as X3D. I don't know what's the other format that works with Blender, but X3D seems to be working. So I'm gonna save it into my desktop. SVBox, SVBox para. I'll just save it SVBox2. So hopefully now back into Blender, we're gonna leave this as it is. File, File new, delete everything, File, import, X3D. Luckily we have this X3D format. From what I know, that Blender actually support a lot of format and out of the box. So this is we are very lucky for that. So yeah, we have the box, we have lighting and everything. This guy came out from Paraview, all with nice lighting. And the nice thing about this is that it also has this vertex coloring already working for us, and we can render it inside cycles. So yeah, even though it's not animated yet, like this guy, if we reset the simulations and then play it back, it's not animated yet. I want it to be animated at some point to generate the pattern and then render it out in Blender. For now, we just leave it like this. I'm gonna switch to compositing, material, use nodes and attribute, use a coloring, plug into this guy. We're gonna get a cycles rendering. There you go, cycles rendering this pattern. But I'm not gonna stop right here. I will do a little bit more. So where is it? SVBox, and this is the one as already with the reaction diffusion. So RD, and I'll name it SVBox2. So we already got this guy with a coloring. So now we can turn on sphere chalk. Gonna grab this guy. Oops. We're gonna do the masking thing that we did in the well, actually, color, vertex color. Let me think. SV vertex color. If I'm not wrong, we can grab the vertex color as well. But in this case, I'm not gonna do that. I'm going to use the tissue add-on, and we're gonna get the weighting from vertex color into the vertex group. So if I select the objects and then click on this guy, I'm basically converting the vertex color into weight. Now we have weight. In sphere chalk, we have ways to deal with weight, like this, and then so we are now good to go. So we can simply like grab these objects, and we have this weight value from this guy, and hopefully we can do some kind of masking. So we need a logic functions. We're gonna get the weight, vertex weight from each point, and make a little bit of comparison. And as a result, we're gonna have like a true and false here, and we can use that for our mask vertices. So there's a lot of things to understand here. Go back to object mode, and it should actually work. Scale 2, so everything's correct. I think the value I need to check the value. Oh, the weighting name is incorrect, so call value. Now we should get something. Save this. Let's check, do I get any error? Okay, seems to be working now. This is the original box. Let's look at the vertices. So we are actually, in this case, using the vertices value, but ideally we actually need to look at the polygon face, the color of each polygon face. But you can see, start to see what's is already happening. So we can kind of use the color of each one of this chemical, and then I think we are currently only observing one of the chemical, but yeah, so it's working. Cool. And the nice thing about this, of course, you can always bake it, and you get this real object. And here you can smooth it, but even better, before you smooth it, you use Laplacian. Laplacian smooth is actually something that reaction diffusion is kind of using, if I'm not wrong. And you can kind of smooth out the edge like so, and then make some kind of thickness. I did this a couple of times in my LIVENODING, so you now know the reason why I show you all that. Now we have this result. So save this. I'm gonna use matcap with solid. Okay, matcap doesn't work, so just gonna leave it like this. Turn off everything, and we have this square chop one in the middle. There you go. That's the whole process. But this is only the basic. Okay. From Ready app, which is for a program by Tim Hutton to display these reaction diffusion simulations. There's a lot here that you can play around with. Very cool app. You can think of it like kind of like a pattern generator for now, but of course it's a lot more than that. If you understand the reaction diffusions, just actually YouTube, there's a processing tutorial that talks about reaction diffusion and how you can create it using processing. But you can use Ready, and then you can use a Parafill to convert Ready format, VTO format, VT whatever, and finally you bring it into Blender. So that's the whole process. I'm just gonna leave it here because it's already pretty too long. It's quite long already, and yeah. So at some point, I think the conversion will be simpler from this guy into Blender. But this is how you can kind of mix and blend the two open source program. And with this guy, you can really just export it, maybe a 3D print out, and you get a quite nice design. But that's only like the most basic example I could think of. Yeah, so yeah, let me know what you think, what you can come up with, and I guess I'll see you in the next video. Thank you. Bye.